Hello everyone, welcome to StudyIQ English, your favorite UPSC platform in India. Yes, India has begun its Semicon mission. We are going to become Atmanirbhar in semiconductor processing manufacturing very soon. The government has not only allowed for the processing of 12 extra rare earth materials, but also the government has made it a promise that very soon semiconductors, chips, AI technology, all that for which India has so far dependent on imports. Imports from China, imports from US, imports from Germany, Australia, Chile has to change now. Yes, we are becoming self-dependent. A key strategy towards Viksit Bharat by 2047. And one very important news in that regard is the government's promise to invest more in the 2D material technology. Very often we have heard about the 3D technology. Yes, we know that the government, in order to become quite self dependent in semiconductors, is also experimenting towards more AI innovation. And at the same time, today is in news the 2D technology. Yes, there are some materials which are so thin. They are thinner than anything that you and I can even imagine. And the potential that they have is massive because, yes, they contribute a lot, not only in quantum physics, but also in manufacturing of semiconductors. So, therefore, we have in the news the 2D materials. Very important for GS Paper 3 UPSC mains because this is science and technological developments as well as India's semicon mission. So, quickly, let's have a look. What do you mean by 2D materials? Now, 2D materials, as I said, are wafer thin, super thin materials where only one atom is the width of this material. So, they are only one atom thick. They are thinner than anything we have ever seen or even imagined. A very good example of 2D material could be graphene or MOS2, the molybdenum disulfide, and WS2. These are some examples we use here. Now, why are they important? They are as thin as a sheet of paper, maybe even thinner than that, but only at the atomic level. This gives them a very special property that normal 3D materials cannot have. And 2D materials are therefore atomically extremely thin crystal like structures consisting of either one or very few layers of atoms. Now, since it is extremely thin, it acts as a wonderful electronic, thermal, optical unique structure. These materials are being now researched for the next generation development of electricity energy storage, sensor processing. Apart from that, high strength, flexible, and conductivity materials, and of course, they have a massive usage in semiconductors. Now, you might wonder why suddenly our country is so obsessed about semiconductor manufacturing, that to Atmanirbharta in this sector. The clear answer is green energy. The clear answer is to become self dependent. We all know that by 2030, it is the Indian government who has promised that 40% of our carbon footprint will be reduced as compared to 2005 level. This is our promise made under the Paris Agreement 2015. We also know that we aim today to become a zero carbon economy by 2070. And in this mission, the biggest thing that's going to help us is solar energy. Because yes, India is a solar country. It's a sunshine country. That was the whole purpose of India's initiating the International Solar Alliance in Gurugram back in 2015 also. A group of like-minded sunshine countries who receive higher than average insolation. For example, the biggest one such is in Rajasthan in India because it has a very high grade of insolation. So therefore, we talk about the very famous solar plant there. If you know the name, you can absolutely mention in the comment box. And now to achieve that green solar energy, we need photovoltaic cells. The key material used in these photovoltaic cells are semiconductors. They are thin chips that India needs to manufacture by its own. Given the shock by United States of America, the 55% tariff burden on us, given the fact that China, Australia, Chile, they continue to dominate the semiconductor supply chain, India cannot depend on anybody anymore. And hence comes the importance of more research, more investigation to become Atmanirbhar in semiconductor. For that, an easy raw material is the 2D components. Now, if you remember back in 2010, there was a pair of scientists who had received the Nobel Prize, and these were Andrei Geim and Konstantin Nosolev. Now, these two people had received the Nobel Prize in Physics back in 2010. What was the reason? The reason was their experiment and groundbreaking research in two-dimensional material called graphene. They manually, through the use of sophisticated technology as well, tried to isolate graphene for the first time by separating graphite fragments into thin flakes, which were just one atom thin. And therefore, they realized the exceptional properties of 2D materials, that they are extremely futuristic and they can act as superconductors. So, what are these features of the 2D materials that gives them an edge over other 3D materials? One is that they are very good conductors. While you know that in semiconductor technology, we need to have an alternate because semiconductor means a half conductor, a substance that is neither a good conductor nor a good insulator. It comes in between. So, therefore, the use of superconducting materials in manufacturing semiconductors is awesome. It's great. No wonder 2D materials are displaying a high conductivity. For example, graphene carries electricity much better than copper, and it also spreads heat very fast. Second thing is that these 2Ds are very strong. They are about 200 times stronger than steel, unbreakable absolutely. And yet they are malleable. You can bend them. You can stretch them by about 20%. They are also able to be tuned into or designed into thin chips, which means that they can be engineered into next generation semiconductors. Today, we only depend on silicon. Silicon is a leading material when it comes to semiconductor manufacturing. But these 2D materials like graphene have showed much higher promise, much higher resilience when it comes to their use in semiconductor technology. Then they are also a key ingredient that will go into making quantum bits known as qubits for quantum computing. Again, a great area of research in India right now. And then they are very flexible and transparent. We have seen how flexible they are. 200 times stronger than steel, and yet you can quite twist them and turn them. They are quite flexible. With that, they are also transparent, which means that they can be used for foldable phones. They can be used for gadgets of consumer daily use. And they can also be used for see through or transparent electronics. What's the mechanism of working of these 2D materials? So, the 2Ds, because they are very, very thin, can allow electrons to pass through them very, very smoothly, which means they can be applied to create faster, very quick cooling devices. They are also held together strongly within a sheet, and they are weakly piled up one on top of the other, which means that you can also separate them into super thin layers, even more thin. Now, their energy properties, which are known as the band gap, can also be adjusted by the scientists, which means you can use them in any kind of electronic chip, in any kind of electronic gadget pretty easily. Their thinness also makes them very sensitive to the environment, which means they are perfect for sensors. Every day in the newspaper articles, we see that in India, the noise pollution, the air pollution is on the rise. The Hindu articles every second day actually request the government, they cajole the government to create much better sensors for noise pollution measurement, air pollution measurement, water toxicity, which means sensors have a great role to play. They indicate the level of environmental pollution, the level of noise, the level of light pollution. So, even for a better environment and for climate mitigation, 2D materials can be used to make perfectly accurate sensors. And then they also show quantum effects. We just saw that, like the spin valley coupling, a technique that could power future quantum computers. So, therefore, today they have become a buzzword. The government is ready to invest in them big time. And yes, laboratories across India are being supported by the government. They are carrying independent research to promote the use of more materials like graphene, the 2D, into producing much more semiconductor independence, into producing much more semiconductor materials in India. Ultimately, the goal is to become Atmanirbhar. The goal is to become a tall economy where everything is taken care of within our domestic sphere. A circular economy, a leading economy. So now let's have a look at the question for the day. With reference to the two-dimensional materials, the 2D materials, consider the following statements. 1. Graphene, a single layer carbon atom, is considered the first discovered 2D material. Two, 2D materials are generally exhibiting high strength, flexibility, and excellent electrical conductivity. Three, unlike bulk materials, the 2D materials consists of atoms arranged in three dimensions, giving them a higher thickness and lower surface area. So, which of these statements do you think is valid or are valid? Yes, I have placed the answer for your reference, but you can try also to answer the question. And should you want to initiate a discussion on that, any interesting thread you want to leave here for everyone else to catch up on, then please feel free to use the comment box. And should you enjoy these short videos, if they help you for your UPSC preparation, then please like, share, and subscribe Study IQ English. Thank you.